Hello everyone. Today again we will look at another case study. This time we will look something on the Aditya L1 mission launch. So all of us know that it has been successfully launched. Now let us look at a case study of what was the objective of Aditya L1 mission and what were the payloads that it has carried during this mission. The objective of this L1 mission is to study the upper atmospheric dynamics. It includes the chromosphere and the corona. To study the chromospheric and the coronal heating, physics of the partially ionized plasma, initiation of the coronal mass ejections, and the flares of the sun. It was also done to observe the in situ particle and the plasma environment, providing data for the study of particle dynamics for the sun. Also, the physics of the solar corona and the heating mechanism was also being tested. Another objective was to carry out the diagnostics of the coronal and the coronal loops plasmas as temperature, velocity, and density. Then the development of dynamics and the origin of CMEs um, to identify the sequence of processes that occur at multiple layers, the chromosphere, base, and the extended corona, which eventually leads to the solar eruptive events. To study the magnetic field topology and the magnetic field measurements in solar corona. To understand the drivers for space weather, origin, composition, and the dynamics of the solar wind. Now, what is the uniqueness of this solar machine? It is the first time spatially resolved solar disk in the near ultraviolet band. Coronal mass ejection, that is what the CME is. Coronal mass ejection dynamics close to the solar disk, that is from about 1.05 solar radius, thereby providing information on the acceleration regime of the CME, which is not observed consistently. Onboard intelligence and to detect the CMEs and the solar flares for optimized observations and data volume. Direct and energy anisotropy of solar wind with using multi-directional observations. So let's get move on. Aditya L1 mission payloads are seven. All of us know that it is around seven payloads, and all the payloads have been, we have listed down here. Um, has been developed by various institutions inside the country with the collaboration of ISRO. The first one is a visible emission line coronagraph, or VELC. It studies the solar corona and the dynamics of coronal mass ejections. It was developed at the Indian Institute of Astrophysics in Bangalore. The Solar Ultraviolet Imaging Telescope. It images the solar photosphere and the chromosphere in near ultraviolet or UV, and also measures the irradiance variations, solar radiance variations in near ultraviolet. This instrument, or it's called as a suit, was developed at the Inter-University Center for Astronomy and Astrophysics, Pune. This is a larger picture where you see the telescope being shown in with various parts. The third one is the Aditya Solar Wind Particle Experiment, or aspects. Now, it is there are two things. The PAPA as well as the aspects. The aspects instrument was developed at the Physical Research Laboratory, Ahmedabad, and the next one, that is the plasma analyzer package for Aditya, uh, is which is also studies the energy distribution, etc., was developed by Vikram Sarabhai Space Center at Trivandrum. These are designed to understand the solar winds and its composition and do mass analysis. The solar low energy X-ray spectrometer studies the X-ray flares from the sun over a wide X-ray range in an X-ray energy range. It was developed at the UR Satellite Center, Bangalore. We see it here for SOLEXS. The high energy L1 orbital X-ray spectrometer or Helios or HEL1OS, like Helios, it is you don't pronounce that. The It studied the X-ray flares from the sun over a wide X-ray range, energy range. It was developed again at the UR Satellite Center, Bangalore. The seventh payload, or the magnetometer, is capable of measuring an interplanetary magnetic fields at the L1 point. And the magnetometer payload was developed at the Laboratory of Electro-Optic Systems at Bangalore. We see here the PAPA and the SUIT is here, the VELC is here, SWIS is here, the Helios, etc. All these are the seven payloads. Now, the payloads can be divided into two. One is remote sensing payloads, the VELC, the SUIT, and the SOLEX, as well as the Helios. They are all remote sensing payloads. And you have the in situ payloads, or the aspects, PAPA, and the high resolution digital magnetometers, right? So this one is the kind of um, various uh, payloads that the Aditya has been launched, and we all know that it was launched successfully on the September 2nd at the 11:50 a.m. In fact, we had the privilege of seeing the launch uh, in the during live, and the orbit of L1 was set in the Sun Earth L1 system, which is a Lagrange one, where the gravitational pull of both the bodies is balanced out, of both the Sun as well as the Earth for the satellite. Okay. The budget is around $46 million, has been said at, in 2019. It was launched at Sriharikota Spaceport, and there are references, whatever that we have taken for making this case study is from this um, website. Thank you very much. It has been wonderful explaining things about this Aditya trajectory. Aditya L1, L1 stands for the Lagrangian one. Okay. Thank you very much. We'll meet again on another case study. Thank you. Till then, bye.